Hi guys, today for Chem 2 we're going to be talking about titrations. So there's two cases that I just wanted to go over. One is if you're titrating a strong acid with a strong base, and the other is if you're titrating a weak acid with a strong base. So the first thing that you want to do when you're doing a titration is determine how strong your acid is. So if it's one of the 6 strong acids, then obviously you know that's the type of problem that you're dealing with. And so the first thing that you want to do is find your equilibrium volume. So this is the volume of base that you'll add to your solution that'll make it so that your moles of base equal your moles of acid. So that's really what a titration is doing. You're trying to make it so that you neutralize the solution that you have. So the only way you can do that is add an equal amount of base to the amount of acid that you have. So to find this volume, it's really simple. You just take your concentration of your acid, multiply it by the volume of your acid, and then divide by the concentration of your base. So that'll tell you how many milliliters of your base that you need to add to your acid to neutralize it. So there's a couple different situations you might be in during your titration. The first is if your volume of base is your volume of base is 0. So this is when you first begin your titration. So obviously you haven't added any base yet. So to calculate the pH at this point, it's really simple. If you're a strong acid, the concentration of your protons or your hydronium, which is H3O+, is simply going to be equal to the concentration of your acid. And so it's really easy to figure out your concentration of your protons, and then the pH equals negative log of your proton concentration. So that's pretty much the easiest position you might be in. The second one is if your volume of your base is less than your equilibrium volume. So what you do here is you calculate by doing milliliters of base, you do your volume of base that you've added times your concentration of base to find the moles of base that you've added, and then you subtract your moles of base from the moles of acid. So you're really determining how many moles of your acid have been reacted with the base. Moles of base. And then whatever hasn't reacted with the base yet is going to determine your pH. So this will get you a leftover moles of acid. So then you can turn this into a concentration of your acid that hasn't been reacted with a base yet. And then you take the negative log of this term to get your pH. So the next situation is if your volume of base equals your volume equilibrium. And this is a really great situation because if it's a strong acid, you can just automatically assume that the pH equals 7. So, yay! And then the last situation just have to erase all this. So the last situation that you'll encounter is if your volume of base is greater than your volume equilibrium. So this is very similar to when your volume was less than your equilibrium volume, except instead of calculating your unreacted moles of acid, you're going to calculate your unreacted moles of base. So again, you're going to take your volume of base times concentration, and that'll get you some moles of base. And now the only difference is, instead of subtracting moles of base from moles of acid, you do the opposite. So you do moles of base minus moles of acid, and you'll get some term which is an unreacted molecular amount of base, and then you'll convert this to a concentration. That concentration of your base will be equal to your concentration of hydroxide. So then to find your proton concentration, you do Kw over your hydroxide concentration equals, and then to find pH, again, you just do the negative log of your proton concentration like we did earlier. So that's if you have a strong acid titrated by a strong base. So it gets a little bit different when you're titrating a weak acid with a strong base. And the reason why that happens is simply because your weak acid doesn't fully dissociate in water. So the concentration is going to be a little bit different. So earlier in chapter 15, you learned how to calculate the pH of a solution that's not a fully strong acid. So it's going to be the same for that. So we'll go over the 5 different situations for weak acid as well. So again, you're going to have a situation where your volume of base is less than volume equilibrium. But first you're going to start with 0 base. So to calculate the pH, it's the same as in chapter 15. You can refer back to your book for that. It's a little bit more complicated, but you're ultimately going to be ending up using your Ka value to calculate pH. And then when your volume of base is less than your volume equilibrium but greater than 0, you're going to use the formula. Basically, this is going to be acting as a buffer. So you use the buffer formula, which is pH equals pKa of your acid plus log of the concentration of your base times the concentration of your acid. And then at volume equilibrium, it's a little bit different. So what you're going to do is you're going to end up calculating the different pH based off your not fully dissociated acid, and then comparing that to your base. We won't get into that because it's in the book in quite detail and it'll take too long to cover here. But again, when you're past your equilibrium, so you have more base than you need, it's really simple. Again, you just calculate your concentration of OH the same way that we did previously for a strong acid, and then convert that to your proton, and then take the negative log of your proton concentration to get pH. So that's basically how titrations work. You can also do a polyprotic acid. We won't get into that here just because it'll take too long, but that's also in your book, so if you have any troubles you can always look at that. So yeah.